We begin our course by taking a look at some of the foundational definitions of probability, and we'll take a look at these through the use of a simple example. Consider the following problem. Suppose I take a six-sided die and I roll it. We'll consider this a random experiment, and by random experiment what we mean is any process or activity whose outcome is uncertain, at least to the experimenter. So it might even be that there's a deterministic outcome, but if the experimenter doesn't know what that outcome will be, if there's that element of uncertainty, we'll consider that a random experiment. And that's what probability is all about. It's random experiments and what we can say about them. So let's continue with our example. We roll this six-sided die. What are some of the possible outcomes? Well, in this case, we could roll a 1, a 2, a 3, a 4, a 5, or a 6. And that's it. Those are the 6 possible outcomes. So when we list the possible outcomes, we call that a sample space. So the sample space is going to be a list or a definition of all of the possible outcomes of a random experiment. As we continue on, we're often interested not just in particular outcomes, but what we're going to call events. And so an event is going to be a group or a collection of possible outcomes, rather than an individual outcome itself. So we want to make this distinction. An outcome is one of the possible results. So I roll a 1, that's an outcome. An event, then, is going to be any subset of the possible outcomes within the sample space. So an event can be an individual outcome, or it can be any collection within. So what might some events be for our random experiment where we roll a six-sided die? Let's take a second and just think about that. So what are some possible events? Well, here are some examples. One possible event would be that an odd number occurs, and that includes the group of outcomes 1, 3, and 5. Along with that, then, you could say another possible event would be an even number occurs, 2, 4, or 6. We can go further and say, what about a prime number? So an event could be that a prime number occurs, and that'll include 2, 3, and 5. We could, as we said before, have an event where just a single outcome is included, so a 4 occurs would be an event. We can also have single outcomes that arise as a result of a definition. So a perfect number, which is the sum of its factors. If we say a perfect number occurs, the only perfect number in 1 through 6 is 6. So that limits us to this last possible outcome 6. And finally, we could say something like a factor of 15 occurs, and that would include 1, 3, or 5. And the important thing to note here is that we get the same event, 1, 3, and 5, by saying a factor of 15 occurs as we do by saying an odd number occurs. So different events can lead to the same list of outcomes. Okay, so once we've got these ideas of events in our minds, what we need to do next is define a random variable. And what that means is we're going to take these outcomes and we're going to map them onto a numeric result. So in our case of our die, that's pretty easy to do. We just say, for instance, that we'll let our random variable x be the value that shows on the die when we roll it. So that's a pretty straightforward way to define a random variable for rolling a die. But what about flipping a coin where you have heads and tails? That's not quite so easy to do. So we might do something like 0 if heads shows up, 1 if tails shows up. But we have to be able to take each possible outcome and assign a numeric value to it. That doesn't necessarily mean that each outcome gets a different numeric value. We could, for instance, say, when we roll our six-sided die, that our numeric outcome is a 1 if it's an odd number and a 2 if it's an even number. And that could be the way we define our random variable. But in this case, we'll define it as x is the number that is shown on the die. And once we've defined our random variable, we are in a position to use notation as shown on the screen, where we are interested in calculating what's the probability that this event occurs. So we'll say, what's the probability that x equals 4, and then we'll do the calculation. And that's what the first half of this course is primarily about, is doing this kind of calculation for increasingly complex events and increasingly complex experiments. And at this point, you're now in a position to try exercise 1.3 on page 28 of the Dobro textbook.